morning, all of you. Myself, Dr. K. Viswanath, Allamraju, Professor in the Department of Mechanical Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. So far, we covered in the module of shear force and bending moment diagrams. What is bending moment? What are the types of loads? What are the types of supports? And what are the types of beams? And sign conventions in the case of shear force, what sign conventions of shear force and bending moment calculations. Today we are going to study further calculation of problems on cantilever beam. So here, this is the problem was given. This problem is subjected to a cantilever beam of 1.5 meter of cantilever 1.5 meter long is loaded with a uniformly distribution load. Here uniformly distribution load, a total load at a span of 1.25 meters. So in the middle, at the distance from free end 0.5 meters, there is a point load is acting here, that is 3 kilonewtons. The total length is that 1.5 meters span. So we have to draw the shear force and bending moment diagram for this case. So here the beam is subjected to combination of UDL and point load. So how to calculate the variations of shear force and bending moment values. So there are 4 points we marked here. Suppose in the problem, it doesn't given the points marking, so we have to assume points marking over there. So at fixed point A, and at the starting of the UDL, there is a point D, and end of the UDL is point B, and at point load at point C we considered. So how to solve this problem whenever combination of UDL and point load acts on cantilever beam? Okay, let us see here. Yes, how to solve it. So first we have to calculate shear force calculations. So what is the shear force calculations here? You can see it. These are sign conventions. If you mark a sign convention, you can understand better. There is no confusion. Both positive and negative shear force sign conventions. Okay, from whenever cantilever beam is there, we have to begin with free end. So we are starting from free end. Suppose if the cantilever beam is in this direction is there. If the cantilever beam in this direction, it is fixed at this end. We have to start from left to right. If the cantilever beam is, if the cantilever beam is here, left hand is fixed, right hand is free, then we have to begin from right to left. Okay, here in this case, the cantilever beam is fixed at left hand and free at the right hand side. So we have to start moving from right to left, or to L, right to right direction to left direction. That means free end to fixed end. That is the meaning, that is the principle. Now let us begin. Shear force at point B. What is the shear force at point B? There is no load acting on this. That's why shear force at point B is 0. Now, before going to and shear force at point C, what is the next point? Is this the point? If it's shear force at point C, what is the shear force at point C? There are different points: point B, point C, point D, and point A. So shear force at point C. Shear force at point C means what is there? From up to here, there is a UDL is acting up to shear force SF at C right side and shear force at C left side, so that you can understand the variation at left hand direction and right hand direction, right side of the point C and left side of the point C. Now here at up to point C, what is there? Here UDL is there. What is the uniformly distribution load here? There is 2 kilonewtons per meter, but that is for 2 kilonewtons per meter. For 0.25 meter, how much? 2 into 0.25, that is 0.5 kilonewtons. Now up to here 0.5 kilonewtons acting downwards. But if you cross the point C, then immediately this is also 3 is downward direction. Up to here it is acting at the middle portion of 0.25. Okay, always consider the load, the orientation of the complete load passes through the centroid or center of gravity of the body. Now if we consider 0.25 distance, this 0.25 into 2 into 0.25, that is 0.5 kilonewtons acts in the middle of this. That means 0.25 to distance, 0.25 by 2 distance. This is 0.5 kilonewtons acting. Now see left, go that right left direction. Then it is downwards means what? Section. This is a section line. Section line right side. What is the section line? This is the section portion. Right side. Downwards means what? Positive. Downwards is positive. So it is a 0.5 kilonewtons positive. And 3 kilonewtons also acting throughout that. That 3 kilonewtons plus 3 plus 0.5. That is 3.5 kilonewtons at point C. At B it is 0. At point C it is 3.5 kilonewtons. Okay. Now coming to at point D. Next point is point D. Shear force at point D, how it acts. Shear force at point D, how it is going to act. Now we have to consider this total force of UDL. What is the span of the UDL? This is 2 kilonewtons per meter. What is the total load of the UDL? 2 kilonewtons per meter into meter distance. What is the distance is? 1.25. 2 into 1.25 total load plus 3 kilonewtons also acting over there plus 3. The 3 kilonewtons effect also will be there up to here. So what is 2 into 1.25 plus 3? Then it comes as 2 into 1.25 plus 3. Then total it comes as 5.5 kilonewtons. Up to here, this is at point D. 2 into 1.5, 2 times. Okay. This is 2.5 plus 3, 5.5. That means at point D, 5.5 kilonewtons. At point D, 5.5 kilonewtons. Now, then after that, over here, next go to at point C. There is no load in between. This 5.5 kilonewtons also acts here. Up to here, now this is the section. This is the section line. Section line, right side is downward direction of the force is there. Then the shear force is positive. Yes, downward direction is positive. Shear force is positive. Now here at right side direction, all downward forces are positive. Right side section, this is the section portion, downwards, section portion, downwards, right side, downwards is positive. Now 5.5 kilonewtons will act at point A. Now let us see how to draw this value. What is this value? How to draw those figures? I mean, shear force diagram by those values. At point B, shear force SB, that is we got it 0. Shear force at C. Shear force at C right side is 2 into 0.25, that is 0.5 kilonewtons. Shear force or left side of point C, that is 3.5 kilonewtons. Shear force at point D. What is the shear force at point D? 5.5 kilonewtons. And shear force at point A, that is 5.5 kilonewtons. These are the values are obtained by using sign conventions. Shear force sign convention. We observed those values at point B, point C right, point C left. Why I have drawn point C right, point C left? Because you can understand the variation of shear force, at right side and the left side of point C, how it is going to vary. Now let us start. If you draw a projection lines, yes, this is the relative diagram, this is the loading diagram, this is the load diagram, this is the shear diagram. Yes, now these are the points. If you mark it on this, then what will happen? Let us start, begin. At point B it is 0. Draw a baseline. First what to do? Always draw a baseline. Draw a baseline. This This is the baseline. This line is a baseline. From the, with respect to this baseline, relatively we will draw. Okay, how it is? Shear force at point B is 0. Next, point C. At point C, it came out. How much it is? Point C left side, as I told you, right side 0.5. This distance is 0.5 kilonewtons. At 0.3, immediately what is happening? At 0.5 kilonewtons, it is increased to 3.5. Yes, 3.5. Then next, UDL is there. Wherever UDL is there, what will happen? There is a linearly varying, because shear force diagram, UDL means kilonewton per meter, it is linearly varies. That's why linearly varying. Now suddenly increase it to 3.5 kilonewtons. Then flip from a point C to point D. What is 3.5 to? Next at point D, 5.5 kilonewtons. This is not here. Now proportionately straight increasing linear line. This is a straight line, not a constant line. 3.5 to 5.5. Now 5.5 to here, what is the line? Horizontal constantly. It is a constant. That is point D to point A. It is a constant. Like that, this is a constant line, linearly. Next, decreasing, again linear. Now by understanding shear force diagram, also we can predict what type of load is acting on a structure, on your body. If there is a horizontal line is there, that means there is no, it is a constantly acting. Now if there is inclination is there from point to point, that is the inclined line is there, straight line, not straight horizontal, it is straight inclination, linear line is there. That means in shear force diagram, there is UDL is acting, uniformly distribution load is acting on that body. Now suddenly decreasing means it is decreasing. Otherwise, if there is point load, then it will decreases or increases. Then next, there is again line is there. This is also inclined line, inclined straight line. That is a linear. Then it means UDL is there. This portion UDL, and from here to here, this portion UDL, and there is some point load is acting. That's why increasing and decreasing here we can understand it. And again horizontal line is there. That means there is no load between them. If there is a load, suppose we can interpret better. If suppose there is another load is acting here, some point load, then what will happen? From it will increase, height will increase, like that it goes, effects. Now here there is no point load. Now, okay, so thus we can understand it. Now next, how to draw the bending moment diagram. Yes, first of all you have to draw a bending moment sign conventions so that you will not get any confusion. After practicing period of some problems, more by practice, without sign conventions, directly you can draw without keeping the values. Also directly you can draw the shear force and bending moment diagram. Now this is the way. Now here how to solve the bending moment diagram. This is a load diagram I considered again. In that load diagram, this is the cantilever. Now from where to begin? Load at point B. What is the bending moment? Bending moment at point B is 0 because there is no moment there. At point C, what is MC? So at point C, if we consider this portion, that point C means this much load is acting downwards direction. What is the movement about? This movement is a downward direction. This is the downward means negative, comes under, this is a negative bending moment. Yes, both left side and right, both right side and left side. Yeah, movement, the direction movement is, okay, clockwise, it is in anti-clockwise here, downward direction. That is the better understanding. In the downward direction, then the movement is negative movement. Now, how much load is acting? So what is the movement? What is the movement meaning is all about? Movement means force which is passing through the centroid of the body or through the point into perpendicular distance to that point. Now here, what is the force? This the UDL is 2 kilonewtons per meter. Then 2 kilonewtons per meter into 0.25. How much it is acting? This portion. That portion is 2 into 0.25, 0.5 kilonewtons. Where it is passing through? It is off of the distance, centroidal distance. How much it is? 0.25 by 2. That is 0.125. Now 0.25 by 2. at a distance of 0.25 by 2. Then what is the moment about this? The moment is that 0.5 into distance 0.25, negative 0.5 into 0.25 by 2. This is what here you can understand. That is 0.0625 kilonewtons. At B, bending moment at B is 0. Bending moment at C. This is bending moment at C equal to minus 0.0625 kilonewton meter. Now coming to bending moment at D. What is the bending moment at D? This is the total load. Consider the total load into the distance, half of the distance, half of the span of UDL minus this 3 kilonewtons into 1 meter. Let us go ahead. This is 2 into bending moment at D. That is minus 2 into, that is negative direction. There is a negative movement. Minus 2 into, what is the distance total span? Span of UDL, 1.25 meters. 2 into 1.25 meters. What is the distance half of this span? 1.25 by 2. That is central distance. Minus, this is the 3. What about this 3? This is why it is negative movement. It is acting downward direction. So 3 into, what is the distance? 3 into 2, about this point. That is 3 into 1 meter. Minus 3 into, that is minus 4.563. Minus 4.563 kilonewton meter. Yeah, coming to bending moment at A. What is bending moment at A? Now again, UDL, this total UDL is acting, is the better manner. Bending moment at A. What is bending moment at A? This total UDL, total load of UDL. What is the total load of UDL? 2 into 1.25 meters. That is the total load. 2 into 1.25 meters is the total load. What is the distance? 1.25 by 2 plus 0.25. 2 into 1.25 into 1.25 by 2 plus 0.25 distance minus 3 into, what is the total distance? 1 plus 0.25. About this point you have to take moments. 1 into 0.25, that is 1.25. Now total moment acting at point A by UDL and point load, the observed value is at MA, observed values, that is minus negative 5.94 kilonewton meter. Now we got it at various points, such as bending moment at various points, moment values at various points such as point A, point D, point C and point B. Now we have to go for drawing bending moment diagram. So let us again at B, bending moment at point B is 0, bending moment at C, bending moment at point C is minus 0.625, bending moment at D negative 4.563, negative 4.563, bending moment at A, that is bending moment at A is minus 5.94 kilonewton meter. Our units are in kilonewton meters. How to draw this? Now, as we have studied the variation of the shear force and bending moment at different loads, how the lines becomes. Now, here it is UDL is passing, that UDL is acting up to point B 0, all are in negative direction. That's why it is a negative direction you have represented here. So here, at 0 point C, at point B is 0, at point C, what is the value? Negative minus 0.0625. Very small value, but it is a UDL. That's why passing. Next, now again parabola, parabolic curve comes. Next, point C to point D also is the parabolic curve. What is point C to point D? Why it is parabolic curve? Because UDL is acting. So parabolic curve, parabolically varying, that is minus 4.563. Next, point D to point A, that is minus negative 5.94. That's why it is a straight line. This portion is a straight line portion because there is no load changing. Now it is a parabolic curve. This curve point D to point B, point D to point B UDL is acting, therefore it is changing parabolic. If we draw at a distance of x, if we calculate equation, then it comes as parabolic equation. So that parabolically varying from B to point D, from point D to point A, it is linearly varying. Thus, we can study or we can understand how to draw bending moment diagram. Now here, what is the baseline in the case of bending moment diagram? This is the baseline. Whereas in shear force diagram, this is the baseline. So with respect to baseline, relatively we are going to mention and marking the points and joining those points, then we are getting bending moment diagram. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.